Hello, everyone, and today I'm going to be doing the Exam 1 review for Biology 2101. Sorry, this is coming out a little bit late, but I had a bit of a busy weekend, but here we go. Okay, so number one, all of the mass in an atom is considered to be in the A, protons and neutrons, B, protons, neutrons, and electrons, C, protons only, and D, electrons only. So when measuring the mass of an atom, one proton is equal to 1 AMU. AMU stands for atomic mass unit. And then 1 neutron is also considered 1 AMU. But then you get to 1 electron, and electrons are measured at like 0.0005 AMU. Electrons are really, 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 really tiny. So they are order of magnitude smaller than protons and neutrons. So if we take this into consideration, and we take a look at the periodic table, we'll see that this is consistent with the periodic table. So if, like I said, one proton is equal to one AMU. Well, here you can see that. So hydrogen is just one proton, no neutrons. So it's just one. It just has an atomic weight of 1. Helium has 2 protons and 2 neutrons, so it has an atomic weight of 4. Lithium, 7, beryllium, 9, etc. So when talking about the mass of an atom, we're only considering, we are only considering the protons, and the neutrons. So the answer is A. So next question. One sec. Okay. Just let me pull it up real quick. All right, next question. So number 2 is asking, all of the atoms of the same element will have the same A, number of protons and neutrons, B, number of protons, C, number of neutrons, and D, mass. So if we're talking about all of the atoms of the same element, what doesn't change no matter what is the number of protons. So the answer would be B. Um, what can change is the number of neutrons, right? So if we have a sample of carbon, and this sample of carbon has 6 protons and 6 neutrons, it's still considered carbon. It's still considered carbon. If we change that, oh, this is considered carbon 12. If we change that, carbon has 6 protons and 7 neutrons. It becomes carbon 13. And then the same thing with carbon having 6 protons and 8 neutrons, carbon 14. So what changes here is the mass, because we're adding more neutrons, right? So 6 plus 6, 12, 6 plus 7, 13, 6 plus 8, 14. We're changing the mass. And we're also changing the neutrons. But what doesn't change, what absolutely cannot change, is the number of protons. Because the number of protons is equivalent to changing the element. The number of protons is equal to the atomic number. So atomic number equals number of protons. So if we keep that in mind, right, that means that if we change the number of protons, then the chemical properties of the element also changes. That's also the case with the neutrons, but not necessarily the chemical properties of the element. If we're changing the neutrons, we're really pretty much changing the radioactive properties of the element, because then the atom becomes unstable, etc. So what we're changing is B, the number of protons, not the number of protons and neutrons or mass. An atom will always be the same if it has the same number of protons. So moving on. Let me go ahead and erase this and then pull up number 3. So, number 3 is asking an element with 22 protons, 22 neutrons, and 22 electrons will have an atomic number of A 44, B 22, C 11, or D 66. So, we don't even need to pull up a periodic table for this. It's really simple because we just went over this in the last question. The number of protons is equal to the atomic number. So if we take that into consideration, it's just going to be B. So we don't want to pay attention to 11 because that number doesn't mean anything. And D also, we don't want to pay attention to this because we're adding the number of electrons. But 44 would be the atomic mass. So if we take 22 plus 22, we get 44, right? But we don't want to pay attention to that because we're only asking for the atomic number, not the atomic weight. So we're gonna therefore get B as an answer. All right, so moving on. Just one sec. Let me pull up the next question. You're gonna hear me say that a lot, by the way. So, question 4 is asking which of the following results from the making of a bond? Molecules are broken down. Atoms fill their valence shells with electrons. Electrons are destroyed, or atoms become more reactive. So we could instantly eliminate A because when we're forming bonds, molecules are being built, not broken down. Well, for the purpose of this question, that's correct. Molecules are being broken down only when bigger molecules are involved. But if we're only taking atoms, if we're only taking, like, let's say hydrogen plus oxygen plus hydrogen, we're not breaking down a molecule. We're forming a new molecule. So that's out of the question. So when we're making a new bond, we're not breaking down molecules. And we're certainly not destroying electrons. So this has to do with the one of the thermodynamic laws. I believe it's or I can't remember which thermodynamic law, but it has to do with matter cannot be destroyed nor created. So electrons absolutely cannot be destroyed. Atoms become reactive. That's also not true because when we're making bonds, atoms are becoming less reactive. Atoms are, for example, let's say just sodium metal. If we're just talking about sodium metal really is highly reactive because sodium has, let's use a different color. Sodium has just one valence electron. This is just the valence shell. Sodium has just one electron. So it wants to get rid of this as soon as it possibly can. So sodium is gonna, if we throw, let's see, that's a pool of water, and then this is a piece of sodium. If we put sodium in water, it's gonna blow up. It's gonna blow up because sodium is reacting with the water to become it's become a compound that is far less reactive than sodium in its solid state form. So we're not making atoms more reactive, but we're technically making them less reactive. So that leaves with B. That leaves us with B. Atoms fill their valence shell with electrons. So let's say, so we have the example of carbon, for example. If carbon has 4 valence electrons, sorry if you can't really see that. Let me redraw that. Oh my gosh. Okay, let me just get rid of all this. Okay. If carbon has 4 valence electrons, that means carbon can fill out 4 spaces in which were left empty. So we can fill that out with hydrogen, for example, to make methane or other elements. So what we're doing here is that we're filling the valence shell with electrons. And same case with something like sodium and chlorine. So if chlorine has a valence shell of 7, that means it has one unoccupied space within its shell. So what sodium is going to do, it's going to donate its 1, and then so that makes a full shell for chlorine, making it an anion, and a full shell for sodium, making it a cation. So what we're doing here when we're making bonds is that we're filling the valence shell with electrons. So the answer is B. So moving on. Let's see. All right. I put a bunch of stars in here because I think it's worth explaining it a little more. Okay, so the question is asking for an atom to be considered an ion, it has to be A, protons can outnumber electrons, B, protons equal electrons, C, protons can outnumber neutrons, or D, neutrons can outnumber protons. So, when we're talking about ions, we're not worried about neutrons. So, ions only have to do with electrons. Ions, we're dealing with charge, aka electrons. So when we're dealing with charge, we don't even want to worry. We don't even want to worry about D, neutrons can outnumber protons, or C, protons can outnumber neutrons, because these don't really have to do with anything regarding the question. So when we're talking about A, protons can outnumber electrons, or B, protons can outnumber protons equal electrons. So when protons equal electrons, if let's say we have 7 protons and 7 electrons. If we take 7 plus -7, we're just gonna get 0, right? So if protons equal electrons, then this is considered a neutral atom. This is considered a neutral atom. So if protons outnumber electrons, however, so let's say if we have 7 protons plus 6 electrons, we're going to get 1. So this is positive, aka a cation. So when protons lose electrons, sorry, when atoms lose electrons, it becomes a cation, which is a type of ion, of course. Now, what if we took the same example and made it -8 electrons? Then then we get -1. So then this is negative, which is considered an anion, right? So the answer is A. Protons can outnumber electrons for an atom to be considered an ion. But this is also not the case. This could also be electrons can outnumber protons. That would also be considered an ion. So when we're talking about ions, an ion is just an element. Sorry, an ion is just an atom that is charged. An ion is just an element that is charged. That's really all that's it. That's the case. So just know the definition of an ion, and you'll be solid for the exam. Um, yeah, I don't really have much else to say on that. So let's move on. Just give me 1 second. So number 6 is asking, carbon has an atomic number of 6. How many covalent bonds are therefore formed by carbon? So if we draw out carbon, so if we have an atomic number of 6, then we're going to have, if this is electronically neutral, we're going to have 1, and then 2 on the inner shell, and then 1, 2, 3, 4 occupying the valence shell. So when it comes to forming bonds, we always want to achieve the magic number of 8. So if we see here, carbon only has 4 valence electrons, which means that it has 4 unoccupied spaces in which bonds can be formed. So if we take that, we can make one bond here, one bond here, one bond here, and then one bond here. So the answer would be D, 4. But what if we're talking about nitrogen, for example? So let's go ahead and erase this. Sorry, one sec. It's not letting me. There we go. Let's go ahead and erase this. Okay. So what if this is talking about nitrogen? So nitrogen has an atomic number of 7. So, one sec. Oh my gosh, I'm so sorry. Bit of a mess. Okay. Let's erase this again. So if nitrogen has an atomic number of 7, then we're going to have 1 valence electron, then 2 in the inner shell, and then 1, 2, 3, 4, and then 5. So with nitrogen, it has a valence sorry. With nitrogen, atomic number is 7, number of electrons is 7 if it's electronically neutral. So then nitrogen can make 3 bonds because it has 5 valence electrons. Because we take 8 minus 5 and we get 3, right? Because we have 3 unoccupied spaces. So yeah, that's, sorry for the kind of convoluted explanation, but yeah, that was number 6. So number 7 is asking, which of the following is not true of chemical bonds? A. Chemical bonds form molecules. B. Chemical bonds can occur between 2 identical atoms. C. Electrons can be shared or completely transferred. Or D. Electrons are always shared. So let's work from the top down. So chemical bonds form molecules. That is absolutely true. If that weren't the case, then there wouldn't be anything. nothing would exist if it weren't for this. So chemical bonds form molecules. That is absolutely true. Chemical bonds can occur between 2 identical atoms. This is also true. So carbon can form with carbon. That's not stable though. So, but that could still happen. But if we have nitrogen forming with nitrogen, this is stable. Because this completely occupies the spaces, the valence spaces. Sorry. But yeah, this is also possible. Same thing with bromine. If we're just talking about like neutral atoms, then this is the case. And then chlorine, and then oxygen. This is what we breathe, of course. Yeah. So that's that, right? Um. Yeah. So chemical bonds can occur between 2 identical atoms. That is totally correct. Electrons can be shared or completely transferred. That is also correct. When we're talking about completely transferred, that's like chlorine getting a full valence shell due to sodium donating its 1, right? That's called an ionic bond. And then when we're talking about sharing, that's a covalent bond. For example, between carbon and carbon, that's a covalent bond because we're sharing electrons equally in this case. That's a nonpolar covalent bond. And in the case of oxygen and hydrogen, this is a polar covalent bond because they're shared unequally. But regardless, they are shared. However, when we're talking about electrons are always shared, that is incorrect. So this would be the answer. D. Electrons are always shared because just as the previous question explained, electrons can be shared or completely transferred in the case of ionic bonds. So D. Okay, moving on. So we're moving on to 8. So oxygen has 6 electrons in its outer shell, and hydrogen has 1. With how many hydrogen atoms will oxygen form covalent bonds? That's kind of a confusing question, but we could do this. It's fine. Just kind of take it at face value. If you see a confusing question, feel free to ask questions in the middle of the exam. We'll be happy to answer them. But if we're talking about oxygen, it's going to have 6 on its outer shell. So if hydrogen has 1, well, whoops. If hydrogen has 1, if hydrogen has just 1, then it's just like we talked about earlier. If we take 8 minus 6, we're going to get 2. So that's how many bonds can be formed within oxygen. So bam, and then bam. So that's our answer, 2. With how many hydrogen atoms will oxygen form covalent bonds? And these are known as polar covalent bonds, of course. So yeah, oxygen has only 2 spaces in which it can occupy. So yeah, and this is also the case with something like carbon or nitrogen or bromine. I don't think that's possible, but in terms of like the electronics and whatnot. But or let's say sodium. I don't know if that's possible either. But yeah, anything can form in these unoccupied spaces to make a full electron shell. So that's number 8. So we're gonna need. So just think of water, good old H2O. So oxygen, yeah, you get the idea. So for this example, I'm gonna have to pull up an image real quick. Just bear with me one moment. Okay, I actually need to pull up 2 images, so one more quick second. That was a big mistake. Okay, there we go. Okay, no worries. Oh my gosh, I'm so sorry. This is kind of a mess. Okay, there we go. Jeez. All right. Anyway, moving on. So number 9 is asking which of the following molecules is most likely to bind to an ion and why? So that's a once again a confusing question, but this is molecule A. Molecule A is of course water. This is molecule B, which is methane. So it's asking molecule A because it has an oxygen. It has a molecule with oxygen and is able to bind to an ion. Molecule B because it has a carbon in the center of the molecule. Molecule B because it has 4 hydrogen atoms on the exterior of the molecule. Or molecule A because it has a partial electric charge that will attract an ion. So I'm just gonna cut to the chase. It's answered. The answer is D. So you can tell it's D because methane is a nonpolar molecule. And when we're talking about polarity and polar covalent bonds versus nonpolar covalent bonds, there's an important concept known as electronegativity. Electronegativity is referring to how much affinity a given atom or element has for electrons. So if we look at this chart, fluorine has a very, very high electronegativity, whereas something like Cesium has a very, very low electronegativity. So if we look at this chart, carbon and hydrogen have very similar electronegativities versus oxygen and hydrogen very they have quite a large difference between the electronegativities. And there's a calculation you could do. So 3.5 minus 2.1, this is oxygen versus hydrogen. That of course is equal to 1.4. So if we so yeah, and then we have carbon, which is 2.5 minus 2.1, and this is equal to zero point 0.4. So if something is less than or equal to point, if the difference in electronegativity is less than or equal to zero point 0.4, then is considered nonpolar covalent. If it is between zero point 0.4 and 2, it is considered polar covalent. If it is above 2, it is considered an ionic bond. For example, if we take chlorine and sodium, for example, that's 3 minus zero point 0.9. That, of course, is 2.1. So yeah, that would be considered an ionic bond. But you don't really you won't get this chart on the exam, and you don't have to know any of these values. I just want to give an example. So this has to do with polarity and polar bonds and non-polar bonds, covalent bonds and ionic, that sort of thing, right? So like I said, answer is of course D, because it has partial electric charges that will attract an ion. So water is a polar molecule because we have hydrogen bonded to oxygen. That would create a polar covalent bond, which would create partial charges such as this one and this one and this one and this one. These would create partial charges within the water molecule, versus carbon and hydrogen, which would create a nonpolar covalent bond. So if it's not charged in any sort of way, if it doesn't have a partial charge or a full charge, then it's not going to attract an ion. So when we're talking about binding to an ion, it's kind of strange because it's not technically a hydrogen bond, but it's also technically not a hydrogen bond, but it's also not an ionic bond. But yeah. So if we draw out water, right, and we have the partial charges. So we have the partial charge here on hydrogen, then that's going to attract the fully negative charge, on chlorine. Those are going to bond together. They're going to be electrically attracted to each other. I don't want to say bond necessarily, but yeah. So and then here on the opposite side of water, we have a partial negative charge which would be attracted to a sodium ion. So yeah, that's kind of what's happening here. It wouldn't be molecule B because that's again nonpolar, and having carbon in the center doesn't really have anything to do with it. And then oxygen with a molecule with oxygen is able to bind to an ion. That's also not true because if you just have oxygen bind to another oxygen, this is considered nonpolar because if we take 3.5, which is the electronegativity of oxygen, minus 3.5, we get 0. So this would be considered nonpolar. Yeah, polarity is something I get a lot of questions on, and there's a lot of confusion surrounding it. So feel free to message me if you have any questions, if you have any further questions regarding the matter. But anyway, we're moving on to the next question. So let's see. Okay, the next question. Okay, I'm actually gonna do this because I actually ended up needing this, right? Okay, so I'm just gonna erase this. Okay, so the question's asking, water is a polar molecule because A, hydrogen is more electronegative than oxygen, B, oxygen is more electronegative than hydrogen, C, hydrogen has more neutrons than hydrogen, D, oxygen has more electrons than hydrogen, or E, hydrogen has more neutrons than oxygen. So immediately we could eliminate, whoops, immediately we could eliminate E and C because we're not talking about neutrons. Neutrons barely have anything to do with anything in this class, except for the case of isotopes. So don't even worry about neutrons if we're not talking about molecular weight or isotopes. So neutrons out of the question. Um, D, oxygen has more electrons than neutrons. That doesn't really have anything to do with it either, because when we're talking about polarity, we're talking about the sharing of electrons. Sorry, with the unequal sharing of electrons. So if oxygen has more electrons than hydrogen, that doesn't necessarily have to do with anything. It just has to do with electronegativity and how closely oxygen is going to keep those electrons next to it. So if we're once again, if we're taking a look at this electronegativity chart, we could see immediately that oxygen has one of the highest electronegativities in the entire periodic table. So 3.5 versus 2.1, yeah, A is out of the question as well. So the correct answer would be B. Oxygen is more electronegative than hydrogen. And we kind of already went over why that would make a polar covalent bond. It's a polar molecule because it's making polar covalent bonds. It's only consisting of polar covalent bonds, which is the unique thing about water, is that it's small, only has polar bonds, and is less dense as a solid than it is as a liquid. So those are the unique properties of water, but we're not really talking about that here. So what we're talking about here is electronegativity. That has to do with polarity always, right? When we're talking about electronegativity, just always think like, what kind of bond are we making here? So oxygen, since like I said, since the unequal sharing of oxygen, the unequal sharing of electrons in oxygen versus hydrogen is very great, right? It's going to have an unequal it's gonna have poles. It's gonna create poles. So over here is the negative pole. Over here is the negative pole, and then over here is the positive pole. So it's gonna create that pole because we're having a high density of electrons here in this area of the molecule, right? Because oxygen is a bit of an electron hog. It loves to just take up those electrons and whatnot, right? So that's what's happening here. So oxygen is more electronegative than hydrogen. Therefore, water is a polar molecule because it only consists of polar covalent bonds. Moving on. Oops. Where was I? Sorry. Okay, so this question is asking, what is the difference between an ionic bond and a covalent bond? So we kind of already went over this, but we can go over it again. In an ionic bond, one atom accepts electrons from the other. In a covalent bond, the pair of atoms share electrons. In an ionic bond, the atoms share electrons evenly. In a covalent bond, the atoms share electrons unevenly. In ionic bonds, ionic bonds form between atoms of different elements. Covalent bonds form atoms of the same element, and then ionic bonds involve the inner shells versus covalent bonds, which involves the valence electron shell. So immediately we could get rid of D. When we're talking about bonding involving inner electron shells, that's when you get to weird stuff like sulfur or phosphorus. I mean, but we don't really worry about those elements in this class. And besides, don't even worry yourself about bonding to the inner electron shells because we don't really discuss that in this class. So don't even worry about D. D is out of the question. So ionic bonds form between atoms of different elements, and then covalent bonds form between atoms of the same element. That is obviously not true, um, because if we have carbon and hydrogen, that's a covalent bond, and then we have carbon, and carbon. That's also a covalent bond, and then we have, but then we have sodium and chlorine. Well, that's a different. Those are different elements, right? But not necessarily because it's an ionic bond, but not necessarily because they are different elements, right? But we have carbon and hydrogen; those are two different bonds. Sorry, those are two different elements, but they still form a covalent bond. So C is once again out of the question. So then we talk about B. In an ionic bond, atoms share electrons evenly versus in a covalent bond, atoms share electrons unevenly. Um, this this one almost makes sense, but you have to remember your vocabulary, right? We're talking about sharing electrons evenly. If you immediately see sharing, if you see sharing, then we're talking about covalent bonding. So atoms share electrons evenly in a non-polar covalent bond, and then atoms share electrons unevenly in a polar covalent bond. So this is just talking about covalent bonds. So then if we have A, in an ionic bond, one atom accepts an electron from the other, and then in a covalent bond, a pair of atoms share electrons. So that's perfect. Yeah, that's what we're looking for. So the answer is A. So yeah, once again, if you take the example of something like sodium and chlorine, sodium donates its one electron to chlorine, and then they're both happy because they're both electronically stable. So moving on, and then covalent bond. Sure, by now you should know what a covalent bond entails, but anyway. So now we're talking about number 12. Potassium has one electron in its fourth shell, and chlorine has 7 electrons in its third shell. What is most likely to be true? So this is kind of a trick. This question is kind of meant to trip you up, I believe. Um, if you don't have a periodic table in front of you, then it's kind of hard to tell what the fourth shell is exactly. But when we're talking about potassium, it's just going to have one electron on its valence shell, aka its fourth shell. So potassium has just the one, right? And then chlorine has 7 on its outer shell, or its outermost shell, aka the valence shell. So if you take a look at potassium, right? If you Potassium has one valence electron, just like sodium, right? These are both known as alkali metals, I believe, which is why they both have just the one, because they're both in group one of the periodic table. So if you take that example, right? If you just look at what we discussed previously, and the fact that sodium bonds to chlorine ionically because it donates its one, that's exactly what's going to happen here, right? Chlorine is going to gain one electron from potassium. Then potassium is going to turn into a cation, and then chlorine is going to turn into an anion. So the answer would be C. Potassium will give an electron to chlorine to form an ionic bond. Not chlorine will give an electron to potassium. That's not possible. And we're not talking about sharing either, because we're talking about ionic bonding. They will not share at all, pretty much. But you wouldn't really know that without looking at the periodic table. So it's once again, this is kind of feels like a trick question, but yeah, if so, yeah. Anyway, moving on. Okay, so question 13. In hydrogen bonding, hydrogen nearly always pairs with A, oxygen or nitrogen, B, sodium or chlorine, C, another hydrogen, or D, carbon. So, for this, we need to know what hydrogen bonding is. So hydrogen bonding is something that's kind of unique regarding chemistry, right? So if we have here water, right? Water has these two what are known as lone pairs. These are lone pairs of electrons that aren't bonded to anything exist but still exist and still exude a charge. So this would have a negative charge, and this would have a partial. These are both have partial negative charges because they, of course, are electrons, and electrons are negative. And then hydrogen would carry a positive partial charge. So hydrogen, so sorry, so water is unique in the fact that it contains these 4 places in which hydrogen bonding can occur, right? So if we take another water molecule, And this is the case for all water molecules. So if we take another water molecule, then a hydrogen bond is going to form between these because of the partial positive charge on hydrogen. And then this partial positive, this sorry, and then this bond forms because opposites attract, of course. If you ever play with magnets, I'm sure you realize that. Um, but yes, so these are going to be attracted to each other, and then this would form what's known as a hydrogen bond. So the difference between hydrogen bonding and then ionic bonding and covalent bonding, hydrogen bonding is what is known as an intermolecular force versus covalent bonding, which is known as an intramolecular force. Intra means within, inter means between. So this is inter because it's happening between molecules of water. So intermolecular bonding, intermolecular forces. That's what hydrogen bonding would be. So so basically, hydrogen bonding just occurs because these are attracted to each other. And the same thing happens with this oxygen and this hydrogen, right? These are attracted to each other, therefore form a bond. But it also doesn't have to be with necessarily water. For example, in nitrogen, when we have nitrogen which is bonded to three other hydrogens, nitrogen also carries a partial negative charge, and then these three hydrogens have positive partial charges. So what's going to happen here is that they form a hydrogen bond as well because of this partial charge. Because just like oxygen and hydrogen, the sharing of electrons is unequal between hydrogen and nitrogen. So if we're talking about nitrogen with hydrogen and then oxygen with hydrogen, these are always going to be polar covalent bonds, right? And when we have polar covalent bonds, we have the possibility of making a hydrogen bond, which we just discussed. So in this case, after all that, we can consider A to be the correct answer because in hydrogen bonding, hydrogen will always nearly always pair with either oxygen or nitrogen. If despite the name, hydrogen does not bond with other hydrogen, and it certainly does not bond with carbon because that would make a nonpolar bond. And then sodium or chlorine would also be incorrect because that wouldn't be considered hydrogen bonding. That would be considered something else. There's still some sort of attraction to if chlorine is an ion or sodium is an ion. There's some sort of attraction if water is involved, but hydrogen is not necessarily bonded with either of these. So we're talking about oxygen or nitrogen. That is the case. HN or HN or HO. Always polar. Oops. Okay, anyway. Oh, I didn't want to do that. Sorry. Okay, moving on to question 14. So, question 14 is saying, in a bottle of water, hydrogen bonding occurs between the hydrogen of one atom and an or and a hydrogen atom in the same molecule, B an oxygen atom in the same water molecule, C an oxygen atom in the different water molecule, or D hydrogen atom in a different water molecule. So hydrogen. So if we have H bonding, right, hydrogen bonding, since these both have partial positive charges, these are gonna repel each other. So that's out of the question. So we're not talking about D hydrogen in a different water molecule, and then in the same water molecule, like I said, hydrogen bonding would be considered an intermolecular force, not an intramolecular force. So if we're talking about within the same water molecule, that is out of the question. So that so hydrogen bonding would not occur between these two, leaving only an oxygen atom and a different water molecule. Like I said, if we have an oxygen, because this carries a partial negative charge and this carries a partial positive, these are going to create, excuse me, a hydrogen bond. So moving on. So question 15 is asking, which type of bond represents the unequal sharing of electrons? A, a nonpolar covalent bond, B, a hydrogen bond, D, ionic bond, or C, polar covalent bond. Sorry, I read that kind of strange, but so if we're talking about unequal sharing, if we're talking about sharing, we could immediately eliminate D because ionic bond is donation, not sharing. And we can eliminate B because hydrogen bonds, they're not sharing electrons, they're just attracted to each other because of the partial charges. So that leaves polar covalent bond and non-polar covalent bond. So as we discussed earlier, if we're talking about unequal sharing of electrons, that's always going to be polar. Because if we're talking about creating poles, right? If we have positive on this end and then negative on this end, then it's going to be unequal because we're going to have a higher density of electrons on this end compared to this end. So this end is always going to be more positive. So if we don't have these poles, if we don't have these, then it's just going to be nonpolar, right? So we could eliminate non-polar covalent bond, which leaves only polar covalent bond. So moving on from that, this one is a matching question. We could go ahead and just go over this kind of quickly. Just let me pull it up real quick. So matching, choose the item in column 2 that best matches with each item in column 1. Okay, so here we're talking about protons. So protons are gonna so let's see, protons, neutrons, electrons is the weakest type of bond. Results from electrons being transferred from one atom to another or holds the atoms of one molecule of water together. And then on this side we have negative charge, polar covalent bond, hydrogen bond, no electric charge, ionic bond, positive charge. Okay, so protons, positive charge. We should hopefully know that by now. Protons are always going to have positive charges. And then neutrons are going to have no electrical charge because they are electrically neutral. Whoops. And then electrons are going to have a negative charge. Right? So electrons going to be shorthanded to look like this, right? Which will tell you instantly what kind of charge it has. So is the weakest of the bond types. So this would be hydrogen bonding. Hydrogen bonds are broken really, really easily. Whether it be by heat or by motion, hydrogen bonds are broken quite easily. But that does not mean that they are not important, because if we weren't for hydrogen bonding, then life on Earth wouldn't exist. Or life in general wouldn't exist. Anyway, results from electrons being transferred from one atom to another, that would be an ionic bond, because we're talking about transferring of electrons, not sharing. That would be if we're talking about sharing, that would be a covalent bond, and then leaving the last one to be B. So B is saying holds the atoms of one water molecule together, polar covalent bond. Yeah, that's there. There's probably better explanations of what a polar covalent bond is, but that is most certainly the case. So yeah, holds the atoms of one water molecule together, B, polar covalent bond. So that was the matching section. Then we're going to go into a little bit of a short answer. So for the short answer, well, the short answer given on the practice exam, I can go over it really quickly. Yeah, I'm gonna go over it really quickly, and I'm just gonna read out the answer and explain it. Because I don't this question isn't emphasized as much as it is on the Prats exam. But anyway, we could just go ahead and read it out. So this question is worth 5 points, I believe. One, two, three, four. 4 points actually. Sorry. So how are ions formed? Why do ionic compounds readily dissolve in water? And then it says the rules. Okay, so it's saying ions are formed when one atom completely transfers one or more electrons to another atom. So that's true. That's how ions are formed, right? When we have the idea of sodium donating its one to chlorine. Sodium, my valence electrons are kind of crappy, but yeah, that would form an ionic bond because we're donating electrons, right? So that would be formation of an ion. But as for why ionic compounds readily dissolve in water, it's because ionic compounds are made up of oppositely charged ions, and polar water molecules surround the ions and separate them from each other, dissolving the ionic compound. So let me show you what this looks like. So if we have an ion of sodium, what's going to happen is that in solution, water is going to surround it. Because the oxygen of water has a partial negative charge. Now, the bond here that's being formed is not necessarily a hydrogen bond. I want you to understand that for the purposes of this class. This is not necessarily a hydrogen bond that's being formed, it's just an electrical attraction. So that's what's happening here for in the case of sodium, and the same case for chlorine. The same case for chlorine. So that's the same case for chlorine, right? Because hydrogen has a partial positive charge. So these would create an electrical attraction to each other as well. So let me pull up an image of the ion lattice. I feel like this picture is not going to be very good, so bear with me for one moment. Oh, it's actually perfect. Okay. So what's happening here is okay, hold on. Actually, don't know which one is which. Okay, so the purple is sodium. Whoops, sodium, and then the green is chlorine. So what happens? So this is on an atomic scale. This is what your table salt looks like. This is sodium chloride. So this is an atomic scale. So what happens in water is essentially it takes. So what essentially happens is that this water molecule is going to go ahead and then pull apart this chlorine ion, and then this one is going to pull apart this sodium ion, and eventually it just takes it down brick by brick. So if this is considered a house, what water is doing is it's taking it apart one step at a time. And since there's like a bunch of water molecules, this happens very readily and very instantly. So that's why salt dissolves so easily in water. It's because water is essentially just picking apart salt due to polar water molecules, because this is partial positive, of course, and this is partial negative, surrounding the ions, which is pulling it apart, which is dissolving it from a solid to a solution. So that's what's happening with that. Moving on. So I want to go over a couple of other concepts that are not on your Prats exam. So distinguish the terms ion and isotope. Okay, so instantly we could, if it's not instantly, but these are quite different from each other. So ion has to do with the number of electrons. Isotope has to do with the number of neutrons. So already that's a difference between these two. Ions are going to be charged. Ions are always going to be charged. Whereas isotopes, not necessarily. They might be uncharged. They might be charged. If it's charged, then it's still an ion. But isotopes are usually anyway. Anyway, so we're talking about ions, right? Ions will contain greater. Well, how do I explain this? Ions are when the number of protons are unequal to the number of electrons, or vice versa. So if we have more electrons than protons, we have an ion. And then if we have less electrons than protons, we have a cation, right? Oh my gosh, sorry, my mouse is kind of terrible. A cation. So when we're talking about ion, we're talking about charge, basically. And isotope, going back to isotope, I used this example earlier, but let me pull up this image. So if we're talking about carbon, carbon has three major isotopes. We have carbon 12, which is the most common type of carbon. This is 98.9% of all carbon is made up of carbon 12. And then 1.1% of carbon is made up of carbon 13. And then less than 0.0001 is made of carbon 14. So what makes these different, right? What makes these different is the number of neutrons. So carbon 12 will have 6 protons, 6 neutrons. Carbon 13 will have 6 protons, 7 neutrons. And carbon 14 will have 6 protons, 8 neutrons. Right? So what's changing is the number of neutrons. And what changing the number of neutrons does is it makes the atom unstable. So carbon 12, incredibly stable. Nothing's really changing about carbon 12. Carbon 12 is the most stable conformation of carbon, I guess you could say. Whereas carbon 14, why there's so little of carbon 14, is because it's so unstable. Because of having 8 neutrons in that nucleus, it's going to fall apart very easily. So what happens is the atom wants to split, or it wants to lose some of these neutrons to become more stable. So once carbon 14 splits, energy is released. Energy is released, and then it's turned into some other element. Maybe it goes down to carbon 12, or it turns into, let's say, lithium 3 or something. I don't know. This has to do with isotopes. Have to do with more of like nuclear science, but yeah, that's the difference between ion and isotope. The difference is within ions are charged. Isotope has to do with the amount of neutrons and the instability. So that's the difference between the terms. So next question. Why do some atoms participate in non-polar covalent bonds, while some participate in polar covalent bonds? So the simple answer is electron. Whoops. The simple answer is electronegativity. That's a simple answer. The more complex answer is the difference in electronegativity. So if we're talking about oxygen bonding with oxygen, I mean we could pull up the electronegativity chart again if we'd like. Whoops. Sorry, one sec. Okay, if we're pulling we could pull up the electronegativity chart again. Oxygen. I mean, obviously, if you take the same element, it's going to be zero. The difference is going to be zero. So this would be nonpolar covalent, right? Um, so in the same case with carbon and hydrogen, right? If we take the difference in electronegativity between carbon and hydrogen is not great, which so would be nonpolar covalent. If we have oxygen and hydrogen bonded together, that's a great difference. 3.5 minus 2.1, that's a great difference. So this would be polar, right? And the same case with nitrogen and hydrogen. The difference is rather great, so this would also be polar. So that's why some atoms participate in non-polar covalent bonding, whereas some participate in polar covalent bonding. It has to do with the difference in electronegativity. That's the simple answer. So yeah, just know like the difference. But I also want to emphasize carbon and hydrogen always going to be nonpolar. Nitrogen, hydrogen, oxygen, and hydrogen always going to be polar. So I just want to emphasize that as well. So moving on. Um. Okay. We're almost done, by the way. So thank you for sticking with me for so long. Okay, so explain the qualities of a substance that is hydrophilic versus one that is hydrophobic. Use the terms nonpolar, polar, and charged. So, hydrophilic, hydro meaning water, philic meaning affinity for or liking of. So, hydrophilic means it likes water, basically. So, so obviously, water is going to like water, right? So, water is considered polar. And because it's polar, it's hydrophilic. And because it's hydrophilic, it's polar. And it's a sort of like vice versa sort of thing. And then because this is polar, and let's give the example of ammonia again. So N bonded to 3H, that's ammonia. These consist of these consist of non sorry, these consist of polar covalent bonds. This is not a W, this is an N, by the way. This is an N. I'm sorry. Once this is an N. Sorry. So what's going to happen is, since these are polar, this is going to dissolve in this. So this would be considered also hydrophilic. But when we're talking about hydrophobic, however, let's say we always use the example of methane because methane is the easiest one to draw. When we're using the example of hydrophobic is nonpolar. And just remember, I want to also emphasize this: like dissolves like, right? So like dissolves like. So what's going to happen is methane and water are not going to mix. They're going to stay separate because they have different properties. Water is polar, therefore it's not going to mix with a non-polar substance like methane. Methane is non-polar, therefore it's not going to mix with a polar substance like water, right? So it all has to do with charge. So water, of course, has the partial charges on hydrogen and then oxygen. Excuse me. And there are no charges here on methane. There are no partial charges. There are no nothing, right? So, so this would be so it all has to do with charge and attraction to each other. So if we have another methane molecule, these are going to dissolve in each other, right? These aren't going to separate out from each other, but they're not going to mix with water. Just like if we have another water molecule, these are gonna of course make these are gonna be attracted to each other, whereas this is not gonna be attracted to methane. They're gonna separate out from each other. So that's the difference between hydrophilic versus hydrophobic. So hydrophilic equals polar, right? And then hydrophobic equals nonpolar. And then like dissolves like. So that's what you need to know for this question. And then as one final concept I want you to know, we're running at a bit over an hour, so one final concept I want you to know is the difference between adhesion versus cohesion. So let me pull up the example from your textbook. Here we go. There we go. Okay, so cohesion and adhesion explain why meniscus form on a solid surface. Okay, so adhesion is when water molecules stick to something that's not water. All right, so that could be considered like for this example, water sticking to the side of a cup. That's adhesion, which is why if you look at like say a graduated cylinder, if you look at a graduated cylinder, if you have like the milliliter markings and whatnot, if you have water, it's gonna kind of come down like this and then stick to the walls, right? This occurs because of adhesion, because water is sticking to something that is not water. It's creating electrical attractions between the surface. Versus cohesion, cohesion is the attraction is what makes water kind of stick to itself. So if you take like one of those like little water droplet things, or sorry, if you take a pipette, that's the actual name for it. If you take a pipette, right, that's our pipette. That's really bad actually. If you take a pipette, um, you know what? That's even worse. That's our pipette though. If you take a pipette and then we drop it like this, we form like little drops of water. What's gonna happen is that water is gonna kind of like bubble up like this, right? And if we did that with, let's say, methane is not gray, but for the purpose of this example, if we did that same thing with methane would just create like a puddle. Because methane, did I say methane? I meant ethanol. those are really different. But so if we're taking ethanol, ethanol is C2H5OH. This is method. This is ethanol. This is drinking alcohol. So if we're taking ethanol, I need to make this more pronounced. Actually, there we go. So water is gonna kind of bubble up like this, versus ethanol, which is gonna like make it's gonna expand out, right? So what causes this is adhesion. So adhesion is important for something like when you skip a rock across the surface of a lake, or a bug walking across water, or that sort of thing. So anyway, we're done here. So I wish you all the best of luck on the exam, and I bid you all farewell. So take care. Bye.